Good morning, year six. I hope you're all rested after the half term. I hope that you all took a nice break and you managed to relax. But welcome back to our maths, okay? So today is Monday, the 22nd of February, okay? And this week, what we're going to be looking at is actually ratio, okay? So I'll just start sharing my screen now. And as you can see, our learning objective is to identify the symbol for ratio and understand how it can be used, okay? So throughout this week, we're going to be learning about ratio. So our starter is on the board. So I'd like you to just pause the video here, have a quick go at the starter, and then I'll come back to you with the answers, okay? So good luck. Okay, year six. So I'm going to put the answers up right now. As you can see, they are on the board. So number one, 361 times by 23. Okay, so your answer should have been 8,303. So I've got the method up here. We do 3 times 1. I'll put our placeholder in first, sorry. 3 times 1, which gives us 3. 3 times 6 gives us 18. So we put the 8 and then we'll regroup the 1. 3 times 3 is 9. Add the 1 gives us 10. So this is going to be our number up here, 1083. And then we go 2 times 1 is 2. 2 times 6 is 12. So we'll put the 2 and we'll carry the 1 over. And then 2 times 3 is 6. Add the 1 is 7, okay? So these are our 2 rows. We'll do 3, add 0 is 3. 8 add 2 is 10. We'll put the 0 and regroup the 1. 0 add 2, add the 1 is 3. And then 7 add 1 is 8, okay? Giving us 8,303. So well done if you got that. Number 2, what is 2/5 as a decimal? And the answer is 0.4, okay? So the way you could have worked this out is 2 divided by 5, or you should just look at your conversion and know that perhaps 1/5 is equal to 0.2, and then you could just double it, okay? Number 3, the answer was 1,181 minus 837 equals 344. Okay, so that was the inverse, as we know. Number 4, 288 divided by 12 is 24. Okay, so one way that you could have looked at this is by knowing that 12 times 12 is 144, which is actually half of 288. So we would just double it, giving us 24. Or you could have done your bus stop method and you could have just worked out that way, okay? So well done if you got that. Sorry. So number 5, this is actually from last week's lessons, okay? So I hope that you guys had a go at this one. If 5 miles is approximately, I hope you remember that this is approximately equal to 8 kilometers, how many kilometers are in 60 miles, okay? So I've got our method that we've been using up here. And we can see that 5 miles to 60 miles down here, we're timesing by 12, okay? 5 times 12 equals 60. And then on the other side, we'll have to do the exact same thing. So we've got 8 times 12, which gives us 96 kilometers, okay? 96 kilometers. I'll go back to the first slide for number 6. So Mr. Simmons kicked his ball 70 meters. Estimate how far Miss J kicked her ball. So you can see Mr. S, Mr. Simmons here, up to about 70 meters. And I would predict, so if I had a rough look, 10 meters, 10 meters, 10 meters, 10 meters, and then those are 2 10s, 10, 20, 30, 40, 50, 60. Oh, it's a bit, so I'd maybe put 50, I'd say. 50 would be my estimate. I'd say between 45 and 55 is a good estimate, okay? So well done on that question. Okay. So I put our big question on the board here today. So for every 2 blue flowers, there are blank pink flowers. For every blue flower, there are blank pink flowers, okay? And then just below, I've got how many for every sentences can you write to describe these counters? And can you write this using the symbol for ratio? Now, you guys might not be too familiar with the symbol for ratio and how to use it, but hopefully this lesson will enable us to answer this question. So, looking at ratio, okay? Looking at ratio. So, what is ratio? This is the symbol that is used to show ratio, okay? And it looks just like a colon here. I've circled it. That is our symbol for ratio. And what ratio does is it shows the relationship between 2 values and it can describe how one is related to the other, okay? So they can be used to compare. They can be used to compare. Now you can see in my example, I've got a 4 and a 3, okay? And the way you would say this ratio when there is a 4 on one side, a 3 on the other side, or it could be other numbers, is 4 to 3. 4 to 3 is the ratio, okay? 4 to 3. It's important to remember that, okay? So to put it into a little bit of an example, I've got 4 bananas on one side. I've got 3 apples on the other side, okay? So the ratio of bananas to apples is 4 to 3, okay? Is 4 to 3. So that's an example of my ratio. I've got 4 bananas on one side and 3 apples on the other side. So it is 4 to 3. The ratio of bananas to apples is 4 to 3, okay? And if I change these symbols around, if I put the apples on this side and the bananas on this side, it wouldn't make any sense because there's not 4 apples on that side. There are 4 bananas. So our ratio would then switch. Our ratio would then switch to 3 to 4. The ratio of apples to bananas would be 3 to 4. So it would change the other way round, okay? It would change the other way round. It's important to keep that in mind. So this is our correct ratio. Okay, so back to our big question, okay? So for every 2 blue flowers, there are how many pink flowers? And for every blue flower, there are how many pink flowers, okay? So what we're going to do is we're going to attempt to put this into a ratio, okay? We're comparing the two. So for every 2 blue flowers, we've got 2 blue flowers here. How many pink flowers are there? We've got 4. So for every 2 blue flowers, there are 4 pink flowers. Just like in our example, for every 4 bananas, there are 3 apples. For every 4 bananas, there are 3 apples. It's 4 to 3. So for every 2 blue flowers, I might put a 2 in here. For every 2 blue flowers, there are 4 pink flowers, which would make my ratio 2 to 4. The ratio of blue flowers to pink flowers is 2 to 4. But now let's look at it the other way. So for every blue flower, there are how many pink flowers? Now we have to be careful to read the question there because it's not plural anymore. It's not multiple blue flowers. For every 1 blue flower now, how many pink flowers are there? Okay, so we've done for every 2 blue flowers. What about 1? What about 1? For every 1, there is another 2 pink flowers. For every blue flower, there are 2 pink flowers. So that would mean for every one blue flower, there are 2 pink flowers just here, 2 pink flowers. When there are 2 blue flowers, 1 here and 1 here, there are 4 pink flowers, okay? So this is what our ratio does. It tells us this information by comparing the 2 different values, okay? And then for how many for every sentences can you write to describe these counters? There are different colors of the counters in there. So we've got 3 red counters, 3 red counters. Now let's count our blue counters. 1, 2, 3, 4, 5. So we've got 3 red counters and 5 blue counters. So I could write, for every 3 red counters, there are 5 blue counters, okay? And then etc. I would repeat those sentences, okay? So this for every sentence can be really helpful in us understanding our ratios, okay? So can you think of any other things that you could use ratio to compare? So a couple of examples could be boys and girls in the class. So for how many boys are there an amount of girls, or how many girls are there an amount of boys? Pens and pencils. I could have for every 5 pencils, I have 1 pen. Okay, so have a go at writing them, perhaps. Have a go at thinking about how many boys and girls are in the class, and have a go at writing a type of ratio, okay? Have a think about it. Use the phrase for every blank, there are blank to help you, okay? So for every 5 boys in the class, there are 6 girls. You could write something like that, okay? So have a quick little go, give the screen a pause, and then we will move on, okay? Okay, year six. So I hope that you thought of a couple of decent ideas that we could use for comparing things using our ratio. But now I'm just going to go on to a quick true or false question, okay? So this should help solidify our understanding just a little bit more in those statements, okay? So true or false. For every red cube, there are 8 blue cubes. For every red cube, there are 8 blue cubes. For every 4 blue cubes, there is 1 red cube. For every 3 red cubes, there would be 12 red cubes. For every 16 cubes, if there were 16, 4 would be red and 12 would be blue. And for every 20 cubes, 4 would be red and 16 would be blue. Okay, 4 would be red and 16 would be blue. Okay, so have a look at the picture here, the image. We've got 1 red and 4 blues and then another red and 4 blues. Okay, and have a think about true or false. Which ones of these statements are true and which are false? And when you are done, I will come back to you with the answers. Okay. Okay, year six. So I hope that you've had a go at this true or false. I'll reveal the answers now. So the first one is false. For every red cube, there are 8 blue cubes. Okay, so as you can see, there are 2 red cubes here and there are 8 blue cubes. So it would be for every 2 red cubes, there are 8 blue cubes. Okay, so how many blue cubes are there for every red cube? If I cover up this bottom line here, I've got my red cube and there are 4 blue cubes for every red cube, isn't there? The second statement is true, okay? So for every 4 blue cubes, there is 1 red cube, okay? Just as I was saying a minute ago. For every 4 blue cubes, there is 1 red cube, okay? There's not 2 red cubes per 4 cubes, per 4 blue cubes, there's just 1. Okay, so that's true. The third one is also true. For every 3 red cubes, there would be 12 blue cubes. Okay, so the way that we would do this is actually by imagining there's a whole nother row. There's a whole nother row, okay? So I've got, for every 1 red, there are 4 blues here. I've got, for every red, there are 4 blues here. So if I had another red cube here, if I had another red cube here, then I would have another 4 blue cubes. Then I would have another 4 blue cubes, okay? So then for every 3 red, so then if I did have my 3 up here, how many blues would I have? I would have 12, okay? So that is true. And the fourth one now, for every 16 cubes, 4 would be red and 12 would be blue. Okay, so now I'm imagining I had 16 cubes. So that's adding a whole nother row on top again. So I'll draw my row out again. It's very easy to draw things to make it easier for you to look at, okay? So now you can see I've got my 16 cubes and 4 are red. But how many are blue? We've got 4, 8, 12, 16. Okay, so not 12, 16. So that is false. And for every 20 cubes, so imagine once again, I'm adding another layer of cubes. I'll do it down here. I'm adding another layer of cubes. So now I've got 20 cubes. I've got my 1 red and my 4 blue. As I know, 1 red, there is 4 blues. So for every 20 cubes, 4 would be red and 16 would be blue. Okay, so we can count that up. We can count that up. So we've got 1, 2, 3, 4 red, 4 red, 4 red, and then how many blue come with 4 red? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so I didn't actually need my extra line. I'll cross it out. I didn't need my extra line. So for every 4 red cubes, 16 are blue. So this is true. Okay, so well done if you got those correct. I know it can be a little bit tricky to get your head around all of the different phrases and the way that they say everything, but it will soon come with practice, okay? It will soon come with practice, so don't worry too much. So, are me and we, okay? So, our first question is complete the ratio of red counters to blue counters and the ratio of blue counters to red counters, okay? So this is a fairly simple one to start off with. We just need to count up our counters, okay? So the ratio of red counters to blue counters is, so let's count our red counters. 1, 2, 3, 4. So I'm going to straight away put 4. It's a bit confusing, my pen's blue, I know, but just ignore that. So the ratio of red counters to blue counters is 4 red and how many blue? 1, 2, 3, 4, 5. So for every 4 red counters, see, I'm using my for every sentence. For every 4 red counters, there are 5 blue counters. For every 4 red counters, there are 5 blue counters. Okay, so now it's asking it for the other way around. The ratio of blue counters to red counters now. So I'll put the 5 blue counters there at the front because that's what it's asked for first. And then to red counters. So then I'll put the 4 in here. So it's 5 to 4. So the ratio of red counters to blue counters is 4 to 5. And the ratio of blue counters to red counters is 5 to 4. Okay, so it's just the opposite. And like I said in this little star here, diagrams do help. Okay, so if you ever find yourself getting stuck, don't be afraid to just draw out, scribble out a few diagrams which can help you use your for every sentences, and then you can find your ratio. So now our we question, write down the ratio of these numbers. Okay, now before we get into this, I'll stress the difference. Okay, we have 3 different items here. Now we're not just comparing 2 different items, we're comparing 3 different items. Okay, so they might say, like here, strawberries to bananas to blackberries. 3 now. I know that it seems shocking, but it is simply just adding another one to the end. Okay, so you've got your ratio symbol, your small colon, which is telling you how the numbers compare against each other. And if you're doing a third one, you're simply just adding another colon, okay? And the way it is said is from strawberries to bananas to blackberries, okay? So it'd be strawberries to bananas to blackberries, okay? You just add it on the end, okay? You just add it on the end. So for now, for the first 2 questions, I'll scribble this out so that we don't have to worry about it, okay? So now write down the ratio of bananas to strawberries, okay? Now let's remember, it's telling us bananas first, bananas to strawberries. So we're going to count the number of bananas we've got. 1, 2, 3, 4 bananas. So 4. And then to strawberries. So we'll count our strawberries. 1, 2. So our ratio of bananas to strawberries is simply 4 to 2. Okay, 4 to 2. So now I'd like you to have a quick go at the second bit. Okay, so blackberries to strawberries. Blackberries, see what I'm highlighting first, to strawberries. Okay, so I'll give you a second to quickly have a go at that, and then I'll come back and I'll input the answer as well. Okay, Year 6, well done. So what I hope that you've put down, I hope that you've counted the blackberries. 1, 2, 3, 4, 5, 6 blackberries. So I'm going to put my 6 in here. And then as we know, we've got 2 strawberries. So it's 6 to 2. 6 to 2. Okay, so well done if that's what you got. Now, moving on to the trickier one. So now they're asking for 3 different values being compared. Okay, so strawberries to bananas to blackberries. But once again, I'm going to focus on the first one they've asked me, strawberries, which as we know is 2. So I'll put 2 at the start. And then to bananas. So bananas is next, which we have got 4 of. So 2 to 4. And then finally, they've asked for blackberries. So we'll count up our blackberries. We know we've got 6. So it's 2 to 4 to 6, okay? So our ratio of strawberries to bananas to blackberries is 2 to 4 to 6, okay? So what I'd like you to have a go at now is trying the last one on the bottom here, okay? So now it is asking for blackberries to strawberries to bananas, okay? So tell me which ones you think should go first, put it down, and then I'll come to you with the correct answer. Okay, year 6. So what I hope you will have put in these boxes is 6, which is our blackberries, as is the first one, to strawberries. So it's asking for now our strawberries, which we know is 2, and then our bananas, which we know to be 4. So our ratio of blackberries to strawberries to bananas is 6 to 2 to 4. Okay, so well done if you've got that. Now, the last thing I'd quickly like to cover about these questions is a bit of simplification, okay? So I'll briefly go over this. Don't worry about it too much for the first lesson, but it's important that we know it and that it's in our heads, okay? So if I look at my bananas to strawberries ratio, so I'll cover this third one up. If I look at my bananas to strawberries ratio, which we know to be 4 to 2, okay, 4 to 2, we could simplify our ratio, okay? And this is because 4 and 2 can both be divided by 2, can't they? We can simplify it down just like we'd simplify a fraction, okay, or any other number. So 4 to 2, I can divide 4 by 2, can't I? I can divide 4 by 2, which would give me 2. And then can I divide 2 by 2? I can, to give me 1. So if you can do something to one side, you have to do it to the other, okay? Only if it's possible on both sides. So if I tried to divide my 4 by 4, I would have 1, but I can't divide 2 by 4, okay? Because in our ratio, we've got to have whole numbers, okay? So we're going to have whole numbers in this. So it would be 2 to 1 because I can cut both numbers in half, okay? I can cut them both in half, do it on both sides, divide by 2 on this side, and I can divide by 2 on this side as well. Okay, so I can have 2 to 1. Now, once again, keep that in mind. Don't worry about it too much. Okay, we're going to still look for our answers. Don't worry about it too much, but keep it in your mind, okay? Now, this is what I would like you to have a go at. So in the classroom, there are 16 boys, 8 girls, and 2 teachers, okay? So what is the ratio of boys to girls? What is the ratio of girls to teachers? And what is the ratio of teachers to boys? Okay, so you've got 3 different ratios to work out there. You've got 3 different ratios to work out there. And then your challenge is what is the ratio of boys to girls to teachers, okay? So that's one of your triple ratios where you're using 3 different values, okay? And then I've got as well, this can be a little bit of an extra challenge, is can it be simplified, okay? So have a think. Can you divide both sides by the same number to make it simpler? Okay, so give the screen a pause, have a go at this ratio question, and then I'll come back to you with the answers. Okay, year 6, well done. So your answers are up on screen now. Okay, so what is the ratio of boys to girls? So once again, I'm highlighting here, boys is coming first. So I'm looking at the number of boys, 16. So I put 16 down. To girls, it is 8. Okay, so 16 to 8. 16 to 8. Okay, I won't go through simplification just yet. I'll look at that after, okay, if that's what people are screaming down their screens, okay? So what is the ratio of girls to teachers, okay? So I've looked at girls, 8, and I've looked at teachers, 2. So 8 to 2. For every 8 girls, there are 2 teachers, okay? So I'm using my for every sentence. For every 8 girls, there are 2 teachers. And what is the ratio of teachers to boys? For every 2 teachers, which comes first, there are 16 boys. So the ratio is 2 to 16. And then our challenge question, what is the ratio of boys to girls to teachers? 16 to 8 to 2. Okay, now going back to my simplification, can it be simplified? Can it be simplified? Okay, so what is the ratio of boys to girls? We've got 16 to 8, but how do these numbers relate to each other? We must know that 8 and 16 are related. Okay, so can I divide 16 by 2? I can, and it will give me 8. All right, and then I can divide 8 by 2 also, 8 to 4. So our ratio has now been simplified from 16 to 8 to 8 to 4, okay? To 8 to 4, just because we have divided it by 2, okay? But then we've got to look further. Can we simplify it even more? Can I divide by 2 again? So if I divide 8 by 2, it will give me 4. It will give me 4. And then can I divide my 4 by 2 as well? I can, and it will give me 2. Then any further, can I simplify it again? Yes, and I can go even further all the way down to 2 to 1, okay? 2 to 1, okay? So the ratio of boys to girls is actually 2 to 1 when we simplify it down. And simplified the ratio of girls to teachers, we could divide 8 by 2 to give us 4, and 2 by 1, divide 2 by 2 as well, sorry, to give us 1. So it would be 4, and then it would be 1, okay? 4 to 1, 4 to 1. Sorry, that one's rubbish. What is the ratio of teachers to boys? Once again, we can divide by 2. That is the most that this number can be divided by, which would give us 1 to 8, okay? 1 to 8, because we've simplified it. And then the challenge, can we divide them all by 2? Because this one can only be divided by 2 as it's just 2. So if we divide them all by 2, we would have 8 to 4 to 1, okay? So then if we read it out as our for every sentence, it would be for every 8 boys, there are 4 girls and 1 teacher, okay? So that's our for every sentence. That's our for every sentence, okay? So well done if you got that. It's okay if you didn't get the simplified version. That's absolutely fine. We can still work on that, okay? So our plenary, our discussion. What is the importance of ratio? How could we use this in everyday life? How can it help us, okay? So have that little discussion or have a think in your head just for a moment. Have a moment, and then perhaps I'll discuss a little example. Okay, Year 6. So the importance of ratio. Ratio is actually used a lot, okay? We do use this in everyday life. We do use it when we look at our stationery, our pencils and pens. As teachers, we look at it with the boys and girls in the class, splitting up groups, perhaps. We could also use it when cooking to measure out ingredients, the ratio of one ingredient to the other, okay? It can really help us in life. So this is a skill that we're going to be practicing and that we're going to be trying to succeed with, okay? So I hope that we're all starting to understand a little better now. So our success criteria. So once again, our objective is to identify the symbol for ratio and understand how it can be used. So our success criteria is to identify that symbol, which we've done. Look at what you would like to compare first, okay? So look for that first comparison. Use your for every sentences to help, and then check that your answer can be simplified, okay? Check your answer can be simplified. So go on to Teams and complete your assignment for today's lesson, okay? It will be a quiz up there. If you can't access this, please email the Year 6 email and we'll send you the questions over, okay? So well done, Year 6. I hope that we can further understand ratio for the rest of this week, and I will see you tomorrow. Well done.